Hey everyone, welcome. Today we are going to look at the Liskov Substitution Principle, or the L in solid. So what that basically means is that objects of a superclass should be replaceable with objects of a subclass without affecting the correctness of the program, meaning that if I have a class B which is a subclass of A, then the class A should be replaceable with the objects of class B. So that is the whole story behind the Liskov substitution principle. Let's look at some code example. So this example is without Liskov substitution principle. So this does not use Liskov substitution. And let's look at this example. Let's say that we have a character class, and this character has a virtual void move method, and we have another villager in our game which extends the character class, and we override the move method. Now the villager class has some other functionality that the villager can harvest as well. For instance, that our game script or our main script has a list of characters, and we want to call the functions on the characters. So if we use this approach for each character in characters, so both the villager and the character have move function, this would be okay. But if we use character.harvest, since the villager is also character, we will get an error because there is no harvest function in the original character class over here. So how can we solve this? For this we use the Liskov substitution. In simple terms, Liskov substitution is basically a fancy way to say let's just use interfaces. So in order for this example uses Liskov. So in order for our villager to harvest, we will create an interface which has a harvest method, and our villager will now implement or basically extend the character class, which was the original class which only had the move functionality, and it will also extend an iMovable interface. This iMovable interface is simply an interface which only has a move function. So it would look something like this: public interface iMovable, and this will have a void move function like this. So this implements the iMovable and the iHarvester, which is this one which has the harvest function. So from the character class we override the move function, and since we are implementing this harvester interface, so we also need to implement the harvest function like this. Now inside our main game script we will have two lists, one for the movables and one for the harvesters. Now both our character and the villager can move, so we'll create a new list of movables which has a villager and a character, but the harvesters will only have the villager. In the update function we would simply say that for each movable in movers we move, and for the harvester we harvest. As simple as that. With this we have basically solved the problem, and we can now replace the objects of class A with the objects of class B. So the Liskov substitution principle in simple terms is we should create interfaces where we can, and use the interfaces to implement our functionalities so that we can use the objects interchangeably. So adhering to the Liskov substitution principle that basically ensures that subclasses can seamlessly replace their base classes without causing unexpected behavior, and this leads to a more flexible and maintainable code. I hope you guys enjoyed this video. See you in the next one.